Welcome to question 5 of the 2007 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. So for question 5 we have that it is known that 50% of the customers who enter a restaurant order a cup of coffee. If 4 customers enter the restaurant, what is the probability that more than 2 of these customers order coffee? Here we're going to assume that what any customer orders is independent of what any other customer orders. So hopefully you can see that this is starting to resemble a binomial distribution because we've got 2 outcomes with a probability that remains constant between each trial. So that means we could let the random variable x be distributed binomially with n is 4 and the probability of success is a half. Therefore, the probability that we have more than 2 customers ordering a coffee is equal to the probability that 3 of them buy a coffee, added on the probability that all 4 of them buy a coffee. And using our binomial distribution, we have a formula that can be used to evaluate these. So for the probability x is equal to 3, we have 4 customers and we choose 3 of them to purchase a coffee, multiplied by the probability that they order a coffee to the power of the number of customers, and then the probability that they do not order a coffee, which is also a half, to the number of customers who didn't order a coffee. Then we add on 4 choose 4 to purchase a coffee with 1/2 to the power of 4 and then 1/2 to the power of 0. So when we evaluate this, 4 choose 3 is 4, multiplied by 1/2 to the power of 3 multiplied by 1/2 again is 1/16. Then we add on 4 choose 4, there's one way of doing that, multiplied by 1/2 to the power of 4 times 1/2 to the power of 0 is also 1/16. So if we simplify that down, that is equal to 5/16. So that is the probability that more than 2 of the customers out of 4 order a coffee. So from the examiner's report we can see that about a quarter of students got full marks for this question, and students generally either attempted to use the binomial distribution or a tree diagram to assist them with answering the question. Some were unable to evaluate 1/2 to the power of 4 equals 1 divided by 16, and some struggled to evaluate the binomial coefficients. So students should know that n choose n is equal to 1 and n choose 1 less than n is equal to n. Notation was often poor, which made it difficult to ascertain if a student really understood what was required. Common responses were 1/2 to the power of 2 plus 1/2 to the power of 3 plus 1/2 to the power of 4, or a combination of such. Other responses included incomplete tree diagrams. Probabilities that are greater than 1 were also seen, and it's a good time to be reminded that all probabilities must add up to be 1, so we can't have any probabilities that are greater than 1.